Okay. All right. Hello, everybody again. So yeah, my name is Alex Polonsky, and today, along with David Wolmerth and Saheb Arif will over the next hour or so, we'll take you on a virtual tour of the DIY Robocars global community. And I'd like to start with actually kind of from the end with a video, only if Zoom would stop popping down. So this is a video from the Virtual Racing League, and I will talk about this a little bit more of exactly in more detail what it is, but this is actually the track layout that you see here. This is a model of a space that really exists in the physical world, but by going into virtual space, and I'll tell you all about how we got here over time, it allows a level playing field and people from all over the world to join. So this is actually a snippet from the latest race, which was the weekend before last, and it was probably our best race ever. This came about during the pandemic. We had to completely pivot, and this is where I ended up. So this is about 2 minutes long. Enjoy. Our team is the parking lot nerds. Yes, nothing needed.
Great, she's out. Okay. Rainer is, let's see, Drew is in the lead. They're both going really well. The proper race. Oh my goodness, looks like Rainer is trying to pass on the inside. Raider's going to try, go for it. Oh, not on this turn. Perhaps on the next one. Oh, this is a tough one. Looks like Drew's taking a slightly better line through that turn, but Rainer's taking a better line on this one here. And can he move on the inside? Make the move. No. Blocked. Tries on the outside. Blocked again.
Oh, very
now
good.
Passes. Now it's trying again on the inside. Oh, blocked again. Drew, what are you doing? That's amazing.
That's it's a beast.
It is a beast. Oh, what did Rainer just do? He just hit your rear wheel, throwing you off, but doesn't matter. You recover. Rainer's locked wheel to wheel. Can you pull out? Oh my goodness.
We almost don't want to stop this race.
Oh my goodness.
Anyway, I'll stop it here because that was actually the last lap. So the car completed all 3 laps in the race. And now I will kind of walk you through how did we get here and what did you just exactly see? It all started with Udacity. I don't know if many of you are familiar with the Udacity self-driving car nanodegree program, but it is a program that was established, oh man, I'm dating myself maybe here, but it was something like 2017. I had enrolled into, I wasn't the first cohort, but I was, I think, the 3rd cohort. And quickly I realized how just difficult autonomous vehicles are. And if you're interested in Udacity, I'm not going to take the time right now to talk about how Udacity came about, but it's actually a very interesting story that has to do with Sebastian Thrun, who was one of the, he was the professor that led the Stanford team during the 2006-07 DARPA challenge where they won. And they were kind of an underdog against Carnegie Mellon. And then he went to Google, did the whole self-driving car thing and pretty much revolutionized the world. Now he is with Kitty Hawk and so on and so forth. So they built the self-driving car nanodegree program. I enrolled, and then it was just like, you know, I looked at it and I'm like, this is so complicated. There's no way one person can know all the different things about this. So I started the Detroit Autonomous Vehicle Group, which was based on the idea that we could work on the Udacity self-driving car nanodegree projects together. We started out at the coffee shop, at the office coffee shop in Royal Oak. We met there for a couple of months until one of the folks attended, and he told us about i3 Detroit. If you are familiar with i3 Detroit, then you're probably a maker. And if you're not, check it out. I mean, now things are different. So I'm still a member. I don't know what the rules are anymore, but it's a maker space in Ferndale in Detroit. And that's what you see this photo of over here, and have all sorts of equipment. And it was just a perfect fit for what we were doing. They also have a great electronics lab with all kinds of oscilloscope, waveform generators, so on and so forth. So that was the start. So we went from the Udacity self-driving car nano degree program, a bunch of us people met, and then we just started attracting folks around the region, and transitioned over to a local makerspace where we are still members, but yeah, pandemic. So the community. This is the Detroit chapter of the DIY Robocars Global Community. The DIY Robocars Global Community is, there are chapters all over the world. A little bit later in this presentation, I'll show you all the chapters that exist around the world, and it's a very big community now. And the DIY Robocars itself was founded by Chris Anderson, who actually now recently also joined Kitty Hawk with Sebastian Thrun, and maybe some of you know this guy named Larry Page, who co-founded this company called Google. After founding the Detroit Autonomous Vehicle Group, it was just, again, the challenges just kept coming and coming and coming, and you're just like, all right, and then what projects do you work on? How do you scale these things? What do you do? And so I just kept looking around for what else exists out there in the world, and I found that there was a group of folks who were doing very much the same thing out in the Bay Area in a warehouse in Oakland, which was started by Chris Anderson. So some of the guys there who were coming in are, they had sold companies to Google, and I think the Google Translate today, the guy who developed the very first scaled car. So if you look in the picture, we all have scaled cars. So the whole idea is that you take autonomous driving, you scale it down to either 110 scale or 118 scale. The scale can change, obviously. And then you can develop at a very, very, very reasonable cost, especially when compared to a full-size autonomous vehicle. And then Dave and Saheb will show you some live demos of some of the projects that we work on. Here, I'll just show you virtually kind of just in slides, and they will walk you through what it takes to build one of these if you don't already know. And so I emailed Chris and I was like, you guys have essentially built kits, and that now they're really kits, but at that point it was still kind of raw and they weren't really kits, and it still needed a little bit of work, but they were so much farther along than we were. And then they gave us a platform to start with, and we joined up forces. We basically said, all right, let's tackle this thing and try to grow the community further and further. And so we kind of at that point became the Detroit chapter of the DIY Robocars Global Community, which led us to participating in hackathons. And this particular hackathon, I'm going to X out of this, and I'm going to take you to the Hackster page here. So this was a autonomous robot challenge hosted by Hackster, which we actually ended up winning. It was a global event or a global hackathon. And actually Saheb had done a little bit of research, and if you want to chime in, Saheb, you can, but he had done a little bit of research and found out that, especially I think it was in Africa, where they were really struggling with diseased plants and they couldn't catch the diseases in time. And so it was a real problem in the world that we could help solve. So we decided that we could build the Farm Aid Bot. It's a farming aid bot, exactly as the title suggests. And so we built it. And as you can see, it's very much DIY. We had no budget really. So it was everybody donating anything they possibly could. And we built a robot. such as the one that you see here. And then we ended up winning the challenge. We weren't outright winners. There were 5 winners in with different categories, but we did good. And so there was a smaller team. It wasn't a all around, like we didn't, not everybody in the group. Like at this point, I think, so we also have a couple of chapters. We have the Detroit chapter in Ferndale that we used to run out of I3, but now everything is virtual and joined with the entire global community, which I'll get to in a couple of minutes. And then there's also a chapter in Ann Arbor. And each one of those, I don't know, overall, we have like 1,500 people. And so a small group of us came together, and actually most of us are on this call with Dave and Saheb. And we built this bot, and on that day, the Farm-Aid bot was born. So some of the other projects that we work on are anything and everything. Honestly, we've joined even forces with, so I3 runs in a way where they have SIGs. So SIG stands for Special Interest Group. And we are the RoboCar SIG there. And then there used to also be a drone club as well. And so since the technologies, actually even though you'd think there's not that much overlap because one is in the air, one is on the ground, there's actually quite a bit of overlap. And so, especially when it comes to navigating. So topics such as localization, path planning in the air is probably a little bit different than it is on the ground, but still there's a good amount of crossover. And then of course, when you start talking about, ECUs, integrated circuits, systems on chips, very much the same components can be used for both. At the end of the day, in both cases, you're controlling motors. And so, yeah, motors can change, and I know the controls change. All right, hello. But there's quite a bit of crossover. And so we joined forces, and for a while we were even working with the drone club and working on some drone projects. Here, this was just a nice picture. You have everything from, I don't even remember what scale this is. I think this is a 110 scale. Then this is a 118 scale. I don't even know what scale this is. And then this car was the very, very first car that we started with. And it has a very special sentimental meaning to us because it was our first project. So I don't know if you recognize it, but you've probably already seen it in a couple of previous slides. What's so special about that?
1 minute. 1 minute, sorry.
Time?
Yeah, I mean, you have one more minute.
1 more minute?
Yep.
All right. What's special about that car? It was a $25 car that we were able to get our first computer vision and self-stopping technology deployed on. So the whole cost was something like $50. So anyway, the pandemic came about. We were working on all these projects, meeting in person, doing all these things. And then the pandemic came about. So we started the Virtual Racing League. And that's where we took everything in the physical world and tried to transfer it over into the virtual world. This started exactly when the pandemic came about. And that's where the video that you saw, that's actually a map of the actual space in Oakland, California, where the guys race. And by the way, join this weekend. I believe there will be a live Twitch feed where you can watch them racing live. And it's exactly, and the whole idea is how do you correlate the physical world to the virtual world and virtual world to the physical world? So you can, for bigger companies and, when you're on a budget, that equals saving money in the interest of time. So if you're interested in finding I'm guessing most of us are here local, but if you are not local and you need to go somewhere, you can find a local chapter by going to DIYRobocars.com, clicking on resources, local meetup groups. And then you can find a local chapter pretty much anywhere in the world, from Australia to China to California to Michigan to Missouri. In the interest of time, I had a couple of other links that I wanted to show kind of real quick, but I think that we'll probably just go to the questions at this point in time. Obviously, reach out if you have any questions about where to find more information. Last one is here is how to get started with the virtual racing league. It's on DIYRobocars.com. And then there's a guide that will take you through everything. And here are all the chapters around the world, Latin America, blah, blah, blah. Anyway, at this point, I will, you can also see I was the first one to try to form a global community. So yeah, it was a fun time doing all this. But at this point, I think I will take any questions if there are any.
Yes, please ask questions. Okay, yeah.
Sorry, I have a question for you. Regarding you're talking about starting a project here. We want to start with one. What do you recommend us for getting started with this?
What age group and what skill level?
We are 3 engineers of mechatronics, and we are working with university students of first semester.
I would honestly suggest start with the virtual racing league. It's just the cheapest and the easiest. It'll give you an intro. Do they have any experience in autonomous driving?
We just have a little. We don't have any of that. We are starting with this.
I would say it's going to be pretty easy for you probably, but it's going to give you, you're going to ease your way into the entire thing instead of just diving into the deep end of the pool. I would highly recommend starting with the virtual racing league. Also, if you go, there's a Discord channel and there is tons of people in here. There's a ton of us and you are, I would even almost say that almost more importantly than what you're going to learn in terms of like the tech and the coding and stuff like that, you're going to get to meet so many people. And, you know, people are constantly communicating. We have a dedicated channel in the server on Discord, and it's very much a community thing. And then from there, you just, you know, people are constantly talking about their projects and what they're doing, what they're building. Here's Dave again. But, you know, other people are working on projects as well. And I think it's going to benefit you a lot to just get started. And honestly, the virtual racing league, we first started with just us. And now one of the leading guys who's running it, he is a UC San Diego professor. And actually it's a course, he's turned it into a course where his students participate in our events and they get graded. And to get started is very quick. I mean, you guys with mechatronics experience, you should be able to get going within a day, honestly. But then it's just going to expose you to the concepts, and then you're going to just understand how to transfer them over. And then, but then this way you don't have to deal with like the hardware, like the soldering, the things breaking. You just kind of get a pretty solid introduction. The entire pipeline is pretty well ironed out, so you shouldn't have too many issues. And you're going to meet so many people. And then I would say from there, move on to, you know, whatever project you decide to.
Yeah, so
I would
can
say start here.
Yeah, thank you, Alex. Can Rodrigo send you an email for more details how to start?
Yeah, please send me an email.
Okay, yeah, so Rodrigo, you can find his email on the registration page. Okay, we have one question on the chat. Can you talk about drone project briefly?
Haha, Dave, do you want to talk a little bit about the drone project? Nah, I'll take it. Dave has enough to cover in the next whatever time we have left.
Okay, yeah, so yeah, David will be talking more about drone project.
No, he won't. He won't.
Oh, he won't?
The drone project. So the guys, the SIG, the special interest group that joined us at I3 Detroit, they were trying to basically make a drone that can fly itself. And the challenge was honestly they struggled with membership. They struggled with folks, and they didn't get very far. And yeah, they kind of dropped off. And so it's going airborne adds some complexities for sure. But at the same time, like we actually won a drone from one of the competitions that we participated in. And we thought that maybe we could make that autonomous, and instead of having a ground bot such as this one, and this one was targeted for greenhouses. This is not a like super long distance robot. Its primary task is kind of like a Roomba for greenhouses, but to monitor plant health. Turning it into a business case is a whole nother presentation that we can, we can go through, but it's just, yeah, it's expensive, but we wanted to see if we could use drones for this, but drones bring their own challenges, such as they could damage the plants, and how long can they fly for, and what's the edge case scenarios and stuff like that. So I wish I had more technical information to share with you on the drones, but the drones were joined and there was crossover, and the crossover was primarily using GPS for localization. And that's as far as we got. And then those guys dropped off, and I'm not sure where they're at now with this, but that's the extent of work that we have done with drones. It's not as much as I would have liked to. Maybe some of us would have liked to, but definitely there's crossover.
Okay, thank you, Alex. I think, we have another time to ask questions. Now it's time to introduce David. But thank you, Alex, for your presentation. I'll stop recording.